Welcome back to the final lesson of the solutions unit for Regents chemistry. This is more of a cognitive thought type of subject or area. Right? We're not using the reference table. We're not using a calculation. So this really just comes down to a little bit of understanding. So this whole part of the unit is called colligative properties. That's how that's pronounced. You don't really need to know that, right? It's never going to be asked. The word you will never see again, but this is what it is called in science. And what happens is what we're going to do today is we're going to describe how an ionic, specifically, and only an ionic, solute will affect a solution. And the two things that it will affect are your boiling point and your freezing point. And I'll give some examples of what this means. The freezing point depression, right? Freezing point depression is what happens. Now, the word depression means to be low or to be down. And when you add an ionic salt to water, the freezing point of that solution goes down. So the freezing happens at a lower temperature. Right, sorry for the messed up writing. The board's not really cooperating today. All right, but the boiling point elevation is the other thing that happens. And at this point, the boiling point goes up. So essentially, a normal water freezes at 0 and boils at 100. But when you add a salt, what it does is it increases the temperature range in which a solid exists. So we can drop this temperature to -5, and maybe we increase this temperature to 105. So now a liquid water is capable of being liquid at higher and lower temperatures. There are two examples of this in real life, one for each. The first one is salt on a highway. A lot of people have this idea that we throw salt on ice and it melts the ice. Although that's technically true, it's not the best way to think about it, right? Salt on ice, it's not like it's adding heat to melt it. All that's happening is it's taking this temperature that we talked about, the 0-degree temperature, and it's letting water be liquid at a lower temperature. So the water liquefies, the ice liquefies, and doesn't freeze. So I get why people look at it and say it's melting it, but in my understanding of science, right, melting means you're adding energy to move the molecules further apart. And that's not really what we're doing. What we're really doing is dropping the temperature at which freezing occurs. And this allows the water to be liquid. The other example that we talk about is we add salt to water, especially when we're cooking. Now, if you're a cook, you would know that salting the water adds flavor to pasta, for instance, if you're cooking it. And that's true. It also helps cook the food at a higher temperature. So your pasta water, if you use salt, is really boiling at a temperature higher than 100. And what this effectively does is it helps cook the pasta or the noodles a little bit faster. So that's colligative properties. The boiling point goes up, the freezing point goes down. The way this gets a little tricky is when we're dealing with concentration. Right? So, and I'll explain this in a minute, but the higher the concentration of a solution, the greater the effect of the freezing point drop and the boiling point elevation we would get. So if we increased this original solution that you saw in purple, if we increased its concentration, well, now water might be freezing at -10. And if it's freezing at -10, it might be boiling at 110. So it increases that even more than it already was. All right. So here's a typical thing that the Regents tries to throw. Which one of these solutions will have the lowest freezing point? Okay, so it's got to be a solution, number one, to change the boiling point and freezing point of water. Number two, and really importantly, it has to be an ionic solute. This right here is made up of all nonmetals. It is covalent, and therefore it will not affect the freezing point and boiling point. This right here is covalent, and therefore it will not affect the freezing point and the boiling point. At the top end of this, we have two ionic solutions, right? We have NaCl and we have CaCl2. Same concentration, both ionic compounds. Which one would affect it more? That's tricky. But when I explain to you how it's different, how these two examples are different, I think it will make sense. When NaCl dissociates in water, we get two ions, Cl plus and Cl minus. When CaCl2 dissociates in water, we get calcium plus 2, 1 chlorine minus 2, and 2 chlorine minus 2s. So spoiler, this is the answer. And the reason is, even though these concentrations of solute is identical, what that would mean is we would have the same number of moles for the whole molecule. Let's just say that number was, let's just say 10. Right? I had 10 molecules of NaCl and I had 10 molecules of CaCl2. For every 1 molecule of calcium chloride, there are 3 ions that dissociate. So if I had 10 molecules, I would have 30 ions. For NaCl, I have 10 molecules dissociating into 2 ions. That would leave me with 20 ions. Now, what I said up here, the higher concentration of ions is what affects the boiling point and freezing point the most. And so since CaCl2 has more ions when it dissociates, it's going to have the greater effect. Right, so that's really, as far as the Regents is concerned, that's the extent of what colligative properties goes through. What I want to do right now is just kind of show you why this happens. Right? This is not something that you're ever going to be quizzed or tested or asked about for the Regents, but it is good to understand what is happening. So what I'm going to do is I'm going to draw some water molecules right here. Okay, OH, H2O, H2O, H2O. So I'm just going to draw 4 of them. Okay? Now, in the process of freezing, what happens is all of these molecules move close together and they solidify. And when they liquefy, they spread out a little bit more. By adding any ions, we get this interaction of positives and negatives. Okay, so if you remember way back, we were talking about, this is a little review. Oxygens have a partial negative positive charge to them. It's because they have a higher electronegativity. Hydrogens have this partial positive charge to them. And because of that, ionic compounds dissociate and positive things, such as Na+, find their way in between negatives. And things like Cl- find their way in between positives. Right? This is why salts dissolve. So here is why the freezing point goes down. Right? If I go back to this original thing that I was saying before, if I start dropping the temperature, when the water molecules try to freeze, right? Because freezing is when they get close together. When they try to do that and a salt is present, they kind of they're blocking the way. See how this oxygen wants to go freeze with this other water molecule down here? right? It's trying to, but because there is a blockade, right, it almost prevents it from doing so. The only way to get this oxygen and these water molecules frozen is to take even more energy out of the system by lowering the temperature. So the freezing point goes down because these ions are blocking the solidification process, the freezing process. The boiling point goes up for a different reason, but it's the same interaction. So normally, water by itself has these red dotted lines called hydrogen bonds, and they're intermolecular forces of attraction that link them together. That's what gives water a boiling point of 100 because it's a relatively high boiling point. When you add a salt, right, into a solution, you're adding even more intermolecular forces of attraction. What that's doing is it's holding these molecules close together, right? It's holding them closer together. They need even more energy to vaporize, to become a gas, right? And so that's why if they need more energy, what do? They increase the temperature till eventually they get enough energy that they can overcome the forces of attraction, not only of their hydrogen bonds, but also of their ion molecule intermolecular forces that are happening. All right, so this explains why the freezing point goes down. It explains why the boiling point goes up. But you really don't need that for the regions. But it does help you remember it. So I hope you really enjoyed the content from this unit. And I hope I'm helping you understand chemistry a little bit more. I really hope you liked this video if it helped you. Subscribe. Find out when I have more stuff. Check through all of the folders of all the different units, ones that maybe you struggled in. And I'm gonna post a practice test of solutions, right? Everything that the Regents would ask, from old stuff to new stuff. And maybe that will help you even further. So thank you so much for watching. I hope you stay tuned and watch some more of my content.